All right, so this is the last question in the sprint section of the Week 6 Math Counts handout, and it says, how many four-digit integers are there with a digit sum of 31? So for this one, we're just trying to find how many four-digit numbers are there that when you add up all their digits, it equals 31. And it might seem, a little confusing, and the first thing you might want to do is let's just start listing stuff out, right? Like we can do maybe organized counting, start from the highest, we get 9, 9, 9, adding that up equals 27, and then there are 4, and then keep counting. But soon you'll find that that's a lot of numbers, and knowing that this is a math counts question, there's probably definitely, a more efficient way to do this. So it might surprise you that that more efficient way is actually sticks and stones or stars and bars or whatever you want to call it. So yeah, that technique is super useful, multi-purpose. And if you don't know sticks and stones or stars and bars, please, I would just advise learning it in a previous video before looking at this one, because this is definitely not an introductory sticks and stones problem. But in any case, we can think about it like we have 4 digits, right? So those will be our 4 categories. And so we're using our 3 sticks, our 3 dividers, our 3 bars to separate into these 4 categories. So this space, anything in here would represent our first digit, anything in here would represent our second digit, here would represent third, fourth. You get the idea. So you might be wondering, well, are we supposed to be distributing these 31 stones, which represent our 31 digits, into each category? Well, if we tried to do that, we had 31 stones, and I'm not going to draw them out because I really don't feel like drawing out 31 stones. But if we were to distribute them, we could do 7 stones here, 8 stones here, 9 stones here. How many is that? That's 24, and then another 7. So that would add up to 31, and then would it just be well, however many ways you can distribute different combinations of stones into each category would be the amount of digits? Well, if you think about it, there's one problem with this approach, and that's the fact that we could end up with something like 20 stones in that first category, 0, and then 10, and then maybe 1, I don't know, something like that. And the problem with approaching it like this is if this happens, this isn't a valid combination because we can't have 20 stones in the first category. 20 isn't a digit. It's got to be somewhere in between 0 to 9 stones in each category, which means that we would have to do a lot of restrictions and use a lot of complications to solve the question this way. But never fear, we can do something else. Of course we can. And so instead, let's look at this backwards. We know that the highest possible digit sum we can have from a 4-digit number is if we were to have the number 9999, that digit sum of that is 36. So instead, well, let's look at, because we need to end up with a digit sum of 31, let's look at the ways we can take out 5 digits from, anywhere in those 9s. And there's no restrictions on this because even if we were to take 5 digits out of 1 digit, well, it wouldn't matter. We would still have 4, nice digits. So knowing this, we can just say instead, each of these 5 stones, if they're in a category, it represents taking a digit out of that spot. So for example, if we had, 3 stones and then 1 and then 0 and then 1, well, this would represent taking 3 out of that first number, which would be 7, taking 1 out of that second number, 8, taking nothing out and then taking 1 out. And that right there would give you 36. So the amount of ways we can rearrange these 5 stones and 3 sticks will actually give you the amount of ways you can take out 5 from those digit sums, and hence how many 4-digit integers there are with a digit sum of 31. So how do we find, how we rearrange those 5 stones and 3 sticks? And now this is just our classic stars and bars. To do this, we use the choose function. And so we know that we have 3 sticks and 5 stones. So that's 8 total objects. And so the amount of ways to rearrange these 8 objects, just according to sticks and stones, is just we do 8 factorial over 3 factorial, 5 factorial, because that's how many of each object type there are, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, we got 3 times 2 times 1. And then we also got 5 times 4 times 3 times 2 times 1. But because we have 5 factorial on the bottom here, and then we also have it on the top here, that'll just cancel out, leaving us with 8 times 7 times 6 over 3 times 2. So the 6's cancel out, and we're just left with 8 times 7, which is 56 ways to arrange these sticks and stones, hence 56 four-digit integers with a digit sum of 31.